Verifying trig identities. The identity we're asked to verify is the cosine of pi over 2 minus x times the cosecant of x equals 1. So that piece of information was given. What we want to remember is that we can represent cosine of pi over 2 minus x as the sine of x. And the reason for that is the sine of an angle is the cosine of its complement. In other words, the sine of 30 degrees and the cosine of 60 degrees are the same thing. Now that we've rewritten this, we can take a look at cosecant and write it as 1 over the sine. That's just by definition, the cosecant is the reciprocal of the sine. Now, because of the multiplicative inverse property, we get 1 equals 1. This is a true statement, so we have verified the given identity. In this example, the given information was given to us as a fraction, but each one of those trig ratios are themselves fractions. So it's probably a good idea to start by representing the cosecant as 1 over the sine and the secant as 1 over the cosine. And because of the fraction, that indicates division. So we'll rewrite this first equation as 1 over the sine of negative x divided by 1 over the cosine of negative x equals the right-hand side, negative cotangent of x. And the reason we can do that is because of the relationship between cosecant and sine and secant and cosine. Now, when we think of the sine of negative x, that's an angle in the fourth quadrant, if x is between 0 and 90 degrees, and sine is in the first quadrant. So therefore, the sine is negative in the fourth quadrant, but positive in the first quadrant. So I'm going to rewrite that first fraction as 1 over negative the sine of x. But the second fraction can be rewritten as 1 over the cosine of x. Reason for that is the cosine is positive in both quadrants 1 and 4. And now that I have done this, we can just use the property of division that when you divide by a fraction, you multiply by the reciprocal. And now we can multiply the fractions together by multiplying the numerators across and then the denominators across. And now I'm looking at that very first fraction on the left-hand side as another way to represent the opposite of the cotangent of x equals the opposite of the cotangent of x. So this is a true statement, and again, I use the definition of cotangent. Therefore, I have verified this identity.